Hello and welcome. Let's take a look at some homework practice questions from lesson U1A2. In this lesson, we looked at the parent functions: linear, quadratic, reciprocal, absolute value, square root, exponential, and y equals sine x function. And we described the main features of each group of functions. And most specifically, we looked into domain, range, intervals of increase, decrease, continuity, x-intercepts, y-intercept, symmetry, and end behaviors. So the first question says that one of the 7 parent functions examined in this lesson is transformed to yield a graph with the following characteristics. So one of the 7 parent functions means one of the 7 functions that are described on this chart. 1, 2, 3, 4, 5, 6, 7. So the first piece of information given is that the domain is any real number x. So what I would like you to do is go back to the chart and then revisit the domain of each function. So the domain in our question is any real number x, which tells us that it can be a linear function, it can be a quadratic, it cannot be reciprocal because here x cannot be just any real number, right? But it can be an absolute value function, not a square root because x has to be bigger than or equal to 0, but it can be exponential function or sine function. So we're going to say that based on our observations here, or based on this chart, x is any real number, so the domain would be x any real number only in linear, quadratic, absolute value, exponential, and trigonometric functions. So what I'm going to do here is write down all the possibilities that I can yield from the first piece of information. So I'm going to say there is a possibility of it being linear or quadratic or absolute value or exponential function or y equals sine x function. So the trig y equals sine x function. Now, this is not the only condition that our graph should satisfy, so we have to move on to the next piece of information, which is indicating that the range of this function is any real number y, but y has to be bigger than 2. So that should make us think, okay, wait a second. So when you look at linear functions, then the range is any real number y, right? And I'm going to go back to the chart again. So the range for linear is any real number y. The range for quadratics is y bigger than or equal to a number. So that makes me think, okay, maybe the function we're talking about is quadratic. And then when you look at this, you see that the range is y bigger than 2, so not equal to 2. So in quadratic functions, the range is y bigger than or equal to a specific value or a fixed value. So that means that our function cannot be a quadratic function. Now moving on to the next function, that's the reciprocal, but this is excluded already because it doesn't fit in the domain of the given function or the function described in the question. Now here the range is y bigger than or equal to 0, so we have a problem with y being exactly that number. So we're going to say it's not absolute value. Next we have the square root, but square root is already excluded because it doesn't fit in the domain. And then we're moving on to the next function. Here is y bigger than a number, so not equal to. So I think we have a winner right here, but I still want to check and see what happens. Right here, y is any real number less than 1, bigger than -1, so that cannot be part of our graph, so it cannot describe our graph. So we would say that in this case, the only function with a range y bigger than a specific value would be an exponential function. So we're going to cross out some of the options that we came up before. So we're going to cross out linear, because for linear, y is any real number. For quadratic, y is bigger than or equal to 0. for absolute y bigger than or equal to 0, which is the fixed value for the basic absolute value function. For exponential functions, we had y bigger than 0, and for trig, we had less than or equal to 1, bigger than or equal to -1. So we're going to say that in our case, so far, the only function that it has that is satisfying all the conditions listed will be the exponential function. So we're going to say that most likely we are dealing with an exponential function where the domain is any real number x and the range is bigger than 0. Now, the next piece of information given is the information about the end behavior. So we are told that as x approaches -infinity, y approaches 2. So if x is approaching -infinity or positive infinity for that matter, it means that we are given information about the ends of the graph, because x is approaching -infinity on the left end of the graph and positive infinity on the right end of the graph. So we have information about -infinity, and we're told that the y values are stabilizing, so approaching 2. And that reinforces one more time the idea that this must be an exponential function, because in exponential functions, as x approaches one end, the y values will approach the horizontal asymptote. And the horizontal asymptote, obviously, here would be at y equals 2. And the reason why is because the graph of the function is above 2 and it never equals 2. So the values of y are above 2, never equal to, which makes the graph go above the horizontal asymptote. So if you want to put this on a grid, so I'm going to draw the axis here. So the information that we're given is any real number x and the y values bigger than 2, and it seems that we have a horizontal asymptote at y equals 2, which I will draw right now. It's very important that we label the asymptotes by their equations as well. This is the x and the y axis, and we know that the y values must be bigger than 2, which tells us that the graph of this function must be above the horizontal asymptote. So it's an exponential above y equals 2. And remember that an exponential above y equals 2 can either go this way or this way around. So when you think about it, or like how to make the decision which graph would be the one we are discussing here, then we have to look into the end behavior. So the end behavior indicates that as x approaches -infinity, that's the left end of the graph, the y values are approaching 2. So this first option would be the better choice. So the graph of this function would look like this. Now, the equation of the transform function would be y equals 2 to the power of x. And I know that it's 2 to the power of x because we are talking about one of the 7 parent functions, and the exponential function we referred to was 2 to the power of x. And the function 2 to the power of x seems to have been translated up by 2 units, so plus 2. And this would be an equation of the function that satisfies all the conditions satisfied. So I hope this makes sense, and I'm going to take a look in the next video on the next question from the homework in the same lesson. Thanks for watching.